The gravity of the moon pulls the tides, and an entire ecosystem in Mozambique is at their mercy. The shifting seawater turns the whole area into a massive living organism. Estuaries are the lungs of the ocean, and the constant breathing of their tides has formed some of nature's freaks. In this remote lagoon, life has been sculpted by moving water, and over millions of years, these creatures have evolved. But now, their previously hidden world has been found, and they're under threat from an unfamiliar force. The pull of the moon keeps the Earth spinning upright. This regulates the seasons so that complex life forms can develop, adapt, and thrive. It also affects the oceans, causing water to move back and forth in tides. Every 6 hours, these tides change, pushing seawater into the lagoon and sucking it out again. The water is its lifeblood, and the tides are its pulse. This lagoon has been functioning on the coast of Africa for thousands of years. In recent times, its rhythm has been undisturbed for one main reason. The area was the focus of heavy fighting in Mozambique's bloody civil war. While casualties were heavy during the 16-year conflict, the lagoon and its inhabitants stayed untouched. But life here is changing now. This area is a highly desirable paradise waiting to be recolonized. In homemade boats, a small group of humans arrive from the interior, and they like what they see. The lagoon has 4 different areas, and its creatures are custom-made to fit each of them perfectly. At the head of the estuary, fresh water trickles in and mixes with salt. The mangrove forests keep the upper reaches intact. The tidal current flows over seagrass flats. And then it moves into the channel of the mouth where it links with the sea. The rush of the incoming tide pushes this deep seawater into the estuary mouth. Shoals of fry wash into the shallows, providing a valuable food source for many of the smaller sea-dwelling creatures that live in the lagoon. And predators that usually frequent the ocean swim in through the mouth. As the tide rises, the estuary becomes a hunting ground. And the visiting predators each have a different strategy to catch their prey. White pelicans take advantage of the abundant shoals. But human predators also wait to cash in. They net the mouth of the lagoon, intercepting the staple food that the tide brings. These hunters don't target specific prey. They're clever, and they have developed strategies to hunt great piles of food. The seawater shifts over the lagoon flats. At first glance, this looks like an empty weed bed, but these patches are the nucleus of life in the lagoon. The seagrass is the village of weirdness, and between the blades, all sorts of bizarre activities are going on. Many of these creatures are little known to man, but their ingenious designs help them cope with this environment. The cowfisher skeleton is on the outside. It swims around in a protective case. It's one of the only fish that can propel itself backwards and sideways. It's like the remote vehicle of the lagoon. This meter-long sea cucumber is a sediment-collecting specialist. Its entire body is a stomach, and its 8 feathered arms catch and stuff food directly into its mouth. The sand and detritus pass in one end and out the other. It's the processing unit of the lagoon. But it's not the strangest creature here. The cowled nudibranch is a mega slug. It's 7 inches long, and this massive frilled hoop is its mouth. Like a combine harvester, it moves through the blades, cleaning any algae that the tide supplies. Its tiny eyes are almost sightless. It hoovers up everything it comes across. This is a strange set of creatures, but they do have one common purpose. They are designed to hide. They know the incoming tide brings with it a host of dangers. As the sun dips towards the horizon, the tide peaks, and the first visitors arrive over the seagrass. Nightmarish forms hover over the fronds, and the occupants below cower in terror. This is no ordinary predator. The cuttlefish is as good at hunting as the seagrass community is at hiding. They move in slowly and begin to search for prey. They have excellent vision. Their eyes are among the most developed in the animal kingdom. they're also clever enough to blow apart the grass blades, revealing their prey. They can change color and texture by controlling chromatophores in the skin. And their saliva is laced with toxins, making them a formidable predator to deal with. But on the seabed tonight, the hiders have outwitted the hunters. By the time high tide arrives, it's pitch dark, and the seagrass meadows take on a different appearance. Millions of small fish shoal above, and many creatures below capitalize on this. Each predator has its own hunting technique. Some fish are flattened to hide in the sediment. The moray eel doesn't use suction power to hunt. It has to be just as quick, but snaps at the fish as they pass. The carpet anemone uses a different method. The tentacles are sticky, trapping any fish that try to hide in its folds. The anemone shrimp coats itself with the host's stinging mucus, making it immune to the paralyzing effects. It cleverly takes advantage of the struggling fish, picking up the leftovers. In times of poor food supply, the shrimp is much bolder, snipping off a few of the anemone's tentacles to supplement its diet. Crabs use snapping pincers to snare passing fish. They are versatile feeders. The anemone again becomes a source of food. Out on the open sand, a hunting octopus patrols the lagoon floor. Every tentacle gropes and feels around rocks, trying to root out hiding prey. Like the cuttlefish, the octopus institutes a reign of terror in the estuary night. Even fish with toxic spines flee ahead of it. The octopus is highly intelligent. It's able to hunt efficiently and hide when it needs to. Down on the beach, something stirs in the darkness. A female loggerhead turtle has found her way back to the same beach that she hatched on. She carefully digs a narrow shaft and deposits over 100 eggs as fast as she can. She's vulnerable on land. Turtles are hunted by many predators, including humans. So their response is to lay at night. Once the eggs are deposited, she fills in the shaft, compacting the ground above the soft shells to exactly the right pressure. Scattering sand masks the exact location of the egg shaft, confusing any hungry predator that may arrive when she's gone. She turns and lumbers back to the cool of the ocean. As dawn breaks, the tide begins to turn. Water is sucked out, taking nutrients out to sea and exposing the mangrove flats. This is when a different shift of strange creatures emerge. The sand appears to take on a life of its own. Droves of soldier crabs come out at low tide. Unlike most crabs, they can walk forwards. They only have a few hours to feed on the sand before high tide brings back the swimming predators. They process the sand to separate plant matter, leaving little pellets behind, earning them their other name, sand bubble crabs. All this busy activity harvests the new glut of food that every tide brings. But there are other, bigger species that share this low tide window. This is one of the soldier crab's predators, towering over its potential prey. It waits for the masses to emerge. All crabs depend on water, so while the tide is out, this creature draws water up to its body through a web of surface tension created by its hairy legs. The feeding ranks notice the predator too late. The greedy giant grabs the struggling crabs, stockpiling them to eat later. While the water is absent, other weird creatures are exposed. They've all developed ingenious coping mechanisms to survive to the next high tide. Creatures that live here have to deal with the challenges of an alien world before safely returning to their aquatic habitat. These extreme changes trigger the migration of creatures from one environment to the other. Conditions like this could have sparked the spread of organisms from the sea to land. Starfish are left stranded. But these innovative creatures have a hydraulic water vascular system that helps them move about. They keep moist by storing water between their tube feet. On the end of each arm, there is a microscopic eye, which allows the creature to differentiate between light and dark, and to see movement. It has to last through the heat of the day, exposed in the full sun. During very low tides, it may have to retreat to the nearest water to prevent its body tissue from drying out. The low tide brings another burst of frenetic activity. Fiddler crabs also emerge. For them, size is everything. The males sport one outsized claw, which they use to attract a female. At low tide, they perform a special dance of seduction. The females are very fussy about who they choose. The male with the best wave will win her over. Territorial males acquire burrows by forceful eviction. During low tide, the males have a lot on their plate. They need to protect their burrows, attract females, and they need to eat. That big claw may look impressive, but it's not very practical. The males can only use their small claws to feed, making the females twice as efficient in this department. Close by, one of the freaks of the mangrove swamp emerges to hunt. This is a fish, but it can't decide whether it's at home in the water or out. The mudskipper patrols the muddy mangrove beach looking for insects. Its pectoral fins have been modified to act like legs, enabling it to walk on the mud. Large eyes mounted high on its head give it a split-level view, able to see both above water and below. But how does the mudskipper breathe when it leaves the lagoon? It floods a chamber inside its head, surrounding the gills with water. But the predatory crabs hunt here too. This time in packs. Strategically, they work together and close in on their target. But these carnivorous crabs are not invincible. Airborne predators wait patiently for the right moment. This palm nut vulture casts his expert eye on the activity below and swiftly takes advantage. The lagoon extends its limbs up along the estuary into quiet glades of mangrove forest. Feeder streams flow constantly all year round, bringing fresh water into the system. It's filtered through rafts of water lilies and flows into the upper reaches of the mangroves. The barrier of trees protects the delicate mud banks from erosion and storm surge. The root networks create a fortress for smaller fish, impenetrable to larger predators. The mangrove swamp is a functioning city of different levels. The trees convert the sun's energy into food. The rate of photosynthesis is higher in estuaries than in grasslands, forests, and even areas of intensive agriculture. The mangrove trees have evolved a special mechanism to help their offspring survive. The seeds are buoyant and able to float to a suitable spot where they eventually find purchase in the mud and begin to grow roots. White mangrove trees are the early pioneers in the establishment of a mangrove swamp. They stabilize the sediment with their intricate root structure and provide shade for the other species to hide under. Their protruding pencil roots reach for air at low tide. This mud is always waterlogged. Any salt that gets absorbed is stored in leaves and is dealt with in two ways. The white mangrove exudes a high salt concentrate from the base of the leaf, and the black mangrove sacrifices the entire leaf. When it gets too saturated, it turns yellow and is shed, providing mangrove crabs with food. The outgoing tide disposes of many salt-soaked leaves. Even the deeper ocean benefits from the lagoon. Well-fed coral polyps have built massive structures. These reefs provide food for loggerhead turtles, and for this one, which has just laid its eggs, razor clams are a good way to regain strength. She's about to undertake a 50-mile ocean journey to better feeding grounds. She'll need all the strength she can get. Turtles have an onboard navigation system. An iron compound, magnetite, is embedded in their brains and helps them read the Earth's magnetic field. They return to this coast year after year to mate and lay their eggs. Such a healthy reef needs apex predators. Bull sharks and blacktips dominate. But the tigers are here too. The waters off the mouth are valuable breeding grounds for bull sharks, and they'll enter the estuary to give birth to live young. Other species, like the zebra shark, head towards the mouth too. She'll leave a single egg case behind. As the tide flushes the lagoon, it brings with it a new supply of food and nutrients, washing it over the seagrass. The cuttlefish are back, but they're not here to hunt. There are other things on their mind. They only have one chance to breed, and now is the time. The females are attracted to the biggest and most impressive males. Smaller males have to be cunning to win a mate, mimicking the female's behavior and coloration to sneak closer. But the bigger male is having none of it. Since the cuttlefish are preoccupied and aren't hunting, the seagrass creatures can breathe a sigh of relief. The crustaceans are the first to emerge, and they take full advantage to strut their stuff on the seabed. They all have their own personally styled adornments. Some like to carry anemones on their back. Others prefer little sponges. This one stylishly wears a flat pansy shell. But it's not all about looks. These crabs have carefully chosen decorations that serve as camouflage. Some use seaweed, like this decorator crab. This mantle serves two purposes. It provides good cover in the seagrass, and it's a very convenient snack between meals. These creatures are all efficient at what they do, but life on the seagrass flats is about to become even more challenging. The giant intruders have grown in number. There's a bigger human community living nearby, and their demand for food is growing. The mangrove fortress has been breached. Crabs form a large part of villagers' diet. They're an excellent source of protein. With this new predator on the increase, can the lagoon provide for all? Despite the pressure from above, the cuttlefish begin their mating ritual. They've managed to steer clear of the giants long enough to fulfill their life's mission, to procreate. The males challenge each other, getting themselves into position for a final display. During the confrontations, his tentacles are thrown out elaborately at the opponent, and his body color intensifies. The male with the most impressive display wins the female he is courting. The loser retreats quickly. Pairs of cuttlefish dance over the seagrass until the female allows the male to mate with her. Head to head. And as they embrace, the male deposits a packet of sperm into a special pocket on the female. They release each other, but the male continues to guard her while the sperm packet bursts and fertilizes the eggs. Before she deposits the eggs, she sucks up sand granules to coat them and keep them camouflaged. She chooses a place to lay in the seagrass within the male's territory. All this time, the male never leaves her side. The eggs harden, making them difficult for predators to eat. After egg-laying, the exhausted female sinks to the sand. Cuttlefish breed only once. Her life is over. Soon after, the male dies too, offering the ultimate sacrifice for the young. The adults have done all they can. But will their eggs, lying hidden in the grass, be safe? The soft sand at the head of the beach begins to move. This is the start of a unique rites of passage. The turtle hatchlings still have a huge task ahead of them. The pressure is amplified by the giants that now walk the beach on the lookout for an easy meal. The first hatchling gets its bearings and scuttles clumsily towards the water's edge. The leaders may succeed, but this activity will quickly attract attention. And most of the helpless late starters won't make it. The stretch of sand that has to be crossed to reach the sea is a distance of massive proportions. They're so small that the waves drive them back up the beach. But some of them make it to the safety of the ocean, where they'll stay until finally returning to the same beach as their mother did, to lay their own eggs. As the young turtle makes its way out to sea, the outgoing tide sucks rich estuary water onto the reefs. Fish gather in huge shoals to cash in on the abundance of food. Mantas are drawn in by the rich green soup and gather for a feeding frenzy. The horn-like protrusions are efficient scoopers, guiding plankton into the mouth. When the manta hits a high concentration of plankton, it loops to stay in the same area. and more mantas arrive to feed. But those that have eaten their fill sink down and glide over the reef. Here, small damselfish operate a cleaning service, removing parasites that the mantas pick up in the open water. Up above, the biggest filter-feeding fish in the world takes over. The outflow of the lagoon serves up enough plankton to feed the whale shark's 30-foot mass. Female Zambezi sharks begin to move into the mouth of the estuary to give birth, but with devastating results. The fishing nets the humans have left are death traps for the unsuspecting sharks. But some do manage to run the gauntlet, making it into the safety of the estuary, where they will successfully complete their mission. Back on the Seagrass flats, a batch of cuttlefish eggs have survived the 40 days it takes for the hatching to begin. Miraculously, perfect miniatures find their way into the safety of the blades of grass. This estuary is a valuable nursery ground, and many young animals spend their first few critical months here. Each new life that begins here is a product of the whole system. Nothing can be nurtured without the entire lagoon contributing. The residents that we've come to know are shaped by natural forces and not by man. They are the fruit of billions of years of evolution, sculpted by the Earth's relationship to the moon. But can the most feared predator of all fit into this balance and contribute to the future of the lost lagoon?